Okay, here we go. This is the second video in the lesson on derivatives in general, and we're going to work through examples 2, 3, and 4, and these are all going to be similar to your MyOpenMath homework problems from MyOpenMath number 10. Okay, so part A says find the derivative of the function f of x equals x squared plus 7x plus 6. Okay, so we're going to go ahead and use those methods that we did on number 1. Now we don't really have to do it twice, you only have to do it once. I just want to show you what it looks like both ways. So we could say that f prime of a is the limit as x approaches a of f of x, the function itself, minus f of a, the function with a plugged in, over x minus a. All right, now I need to simplify it. So I'm going to distribute the negative, and I'm also going to rearrange the order of the terms a little bit, and you'll understand why as we go through the steps. So we have x squared minus a squared plus 7x minus 7a plus 6 minus 6 over x minus a. Okay, so we can cancel the 6 and the negative 6. And then what we're going to do is some factoring by grouping. So notice that the first two terms, x squared minus a squared, is a difference of squares, and it factors into x minus a times x plus a. And then notice that the next two terms are both multiples of 7, so we can factor out 7, and we have 7 times the quantity x minus a. So notice that we have x minus a as a factor of both parts. We have an x minus a here, and we have an x minus a there. So we can factor x minus a out of both parts. And that's going to leave us with x plus a plus 7. And then we can cancel the x minus a from the top and the bottom. So then what we have now is f prime of a equals, we can go ahead and put a in for x, so we have a plus 7, so that's 2a plus 7. And so what's f prime of x? F prime of x is 2x plus 7. So if this was actually MyOpenMath, we would be putting that in the box, 2x plus 7. Now let's go ahead and do it the other way just to see that we get the same answer both times. So this one would be f prime of x is equal to the limit as h goes to 0 of f of x plus h. So that's going to be x plus h quantity squared plus 7 times x plus h plus 6. That's when we put x plus h into the function minus, and I'm going to have to move some things over here, I think, minus f of x, which is just x squared plus 7x plus 6. Notice that I put it in parentheses, all over h. So now we simplify the numerator. So we're going to square x plus h by multiplying x plus h times x plus h, and we get x squared plus 2xh plus h squared. And then we can distribute the 7 plus 7x plus 7h plus 6, and we can distribute the minus sign, minus x squared minus 7x minus 6. So just like on the last example, we see that the numerator requires a lot of multiplying out and combining like terms. Now what cancels? We have x squared and minus x squared. We have plus 6 and minus 6. We have plus 7x and minus 7x. So what do we have left? 2xh plus h squared plus 7. Let's factor h out of all of those. H times a quantity 2x plus h plus 7. And that's all over h, so we can cancel the h's. And now we evaluate the limit by putting the 0 in for h. 2x plus 0 plus 7 is 2x plus 7. See, we got the same answer both ways. Method number 1 required us to do some factoring. which you might consider more complicated. Method number 2 required us to multiply some things out and combine like terms, which you might consider to be more complicated. It's very subjective which method you like better. Okay, moving on to part B. When x equals 1, then the slope of the tangent line is blank. Okay, remember that f prime of x is the slope of the tangent line. So let's find f prime of 1 by putting 1 in there, and we get 9. So our answer would be 9. And then write the equation of the tangent line to the graph of f of x when x equals 1. Okay, so when x equals 1, what's the y-coordinate of the point? Let's see. F of 1 is 1 squared plus 7 times 1 plus 6. That would be 14. So we have the point 114, and we have the slope, our derivative, 9, and we're just going to put those together to get the equation of the line. This time I think I'll do point slope form. You can use y equals mx plus b or point slope form. 14 is my y1, 9 is my m, 1 is my x1, so y minus 14 equals 9x minus 9, and add 14 to both sides, y equals 9x plus 5. So the box already has before it the y equals, so we just put 9x plus 5. Now I want to use my graphing calculator to show you a verification of that. Okay, so I've typed in the original function, y equals x squared plus 7x plus 6, and I made some adjustments to the window dimensions, and here's the graph. And in the problem, what we did was we found the equation of the line that was tangent to the point 1, 14, right? This y scale is going by 5s. So if I press trace and I type in a 1, you'll see that's the point 114. Okay, here's something fun we can do. We can go to Draw, which is second program. Inside Draw, number 5 is tangent, so we can go down and select number 5. And then we type in the number where we want the tangent line to be drawn, so I'm going to press 1, enter, and you can see a tangent line was drawn. And you can see the equation of the tangent line at the bottom of the screen. Y equals 9x plus 5. That's exactly what we found doing it by hand. So this is a great way to verify your work. And if all you needed was the slope of the tangent line at x equals 1, the derivative at x equals 1, the 9 is the part that you would be looking for to check your work. All right, let's keep going. We have a couple more to do. Here's number 3. Find the values of x where the tangent line to the graph of f of x equals 1 over x is parallel to the line y equals negative 7x plus 6. Okay, let's visualize this. So f of x equals 1 over x looks something like this. It's a rational function. We're supposed to find the point where the tangent line is parallel to the given line that has a slope of negative 7. So we're looking for the point or multiple points where the tangent line slope is negative 7. And remember, the tangent line slope is the derivative. So we want to know where is the derivative. I can spell the word is, really I can. Where is the derivative equal to negative 7? That's what we want to know. Now, in order to figure that out, we need to find the derivative. So I think just to save time, I'm not going to do it both ways this time, but I'll just choose a method. So how about if I choose method number 1, f prime of a is the limit as x approaches a of the function, so 1 over x, minus the function f of a, so 1 over a, divided by x minus a. So f of x minus f of a divided by x minus a. Okay, so we're going to have to figure out a way to simplify this. So this is the kind of problem where you multiply the top and the bottom by whatever your little denominators were. So multiply by x to clear that fraction and multiply by a to clear that fraction. So this is going to be the limit as x approaches a of, multiply both of those by 1 over x, and the x's cancel, leaving you with just the a, minus. Multiply both of those by 1 over a, and the a's will cancel, leaving you with just the x, over, and then on the bottom, let's just leave it as x minus a times x times a. Now remember, 1 minus x, or excuse me, a minus x over x minus a, those are opposites. You can cancel, leaving a negative 1. And then finally, to evaluate the limit, put a in place of x, and we get negative 1 over a squared. So then what's f prime of x? It would be negative 1 over x squared. That's the derivative, so that's the slope of the tangent line. We want to know, where is it equal to negative 7? So I'm going to use this space over here. Let's set it equal to negative 7. We can multiply both sides by negative 1. We can take the reciprocal of both sides and square root. And the directions said give exact answers, not decimal approximations. So it doesn't require you to rationalize denominators. X is equal to negative square root of 1/7, which is the same thing as negative 1 over square root 7, because the square root of 1 is just 1. And x is also equal to positive 1 over square root 7. So notice that it asks you for the greater solution to go in the first box and the lesser solution to go in the second box. You just have to pay attention to the order that they want them. For this problem, just like for the last problem, we could graph our function and we could look at our tangent lines and at those particular points, and we could see that that made sense. I just know that my video is getting kind of long today, so I'm going to skip that, but I would encourage you to give that a try. If you just look at my sketch, 1 over square root 7 is approximately 0.37, so let's just pretend that's right here. So let's say right here we have a slope of negative 7. I mean, I could buy that because it's definitely negative and it looks pretty steep. And then let's say right here is negative 1 over square root 7. Whoops. Also pretty steep, and I could buy that those are parallel for sure. So they both have the same slope, and it's negative. Okay, let's wrap it up with this one. Suppose that the position of a particle is given by s, or just f of t. Sometimes they like to use the letter s for position, but it doesn't have to be. So it equals 4t cubed plus 5t plus 9. Find the velocity at time t. Here's what we need to remember. Velocity, v of t, is equal to the derivative of position, s of t. In other words, velocity equals s prime of t. Okay? So we need to find the derivative of the function we were given, using one of our two derivative techniques. So since on the last problem I used the x goes to a method, how about if on this problem I use the h goes to 0 method? So we have f prime of t is equal to the limit as h approaches 0 of, now in the function we have to put t plus h, so 4 times t plus h quantity cubed plus 5 times t plus h plus 9 minus the function itself, 4t cubed plus 5t plus 9, all over h. So we have to multiply out a bunch of things. And remember we saw earlier that if you have some quantity cubed, you have to multiply it out, t plus h times t plus h times t plus h. So once that's all said and done, you're going to have t cubed plus 3t squared h plus 3th squared plus h cubed for that whole t plus h times t plus h times t plus h thing. And then multiplying through the 5t plus 5h, and then the 9, and then distributing the minus 4t cubed minus 5t minus 9, all over h. And now let's distribute the 4. So we have 4t cubed plus 12t squared h plus 12th squared plus 4h cubed plus 5t plus 5h plus 9 minus 4t cubed minus 5t minus 9 all over h. And remember, if that all went properly, some things should cancel, leaving us just with terms that have a factor of h in them. 4t squared cubed cancels with minus 4t cubed. This is a tongue twister. 5t cancels with minus 5t. 9 cancels with minus 9. Everything we have left, an h, an h, an h, an h. Everything has an h. So let's factor h out of those remaining terms. H times the quantity, 12t squared plus 12th plus 4h squared plus 5 all over h. Cancel that h from the top and the bottom. And now it's time to plug in 0 for h. So we get 12t squared, 0, 0, 5. 12t squared plus 5. Okay, so that's the derivative of position, so that's velocity. V of t is 12t squared plus 5 meters per second. Part B, find the velocity at time 3 seconds. So what we just found was the velocity at time t. All we need to do is plug a 3 in there. 12 times 3 squared plus 5. Let's see. Gonna check my calculator. I'm getting 113. You're going to have similar problems on your MyOpenMath, but they might have different numbers. Usually that's the case, but not always. Part C, find the acceleration at time t. Okay, we haven't talked about this, but if velocity tells you how fast your position is changing, acceleration tells you how fast your velocity is changing. So acceleration, this deserves red, acceleration is a derivative of velocity. This actually deserves its own slide. Remember, we had velocity is a derivative of position. Now we have acceleration is the derivative of velocity. You can take the derivative of the derivative. So let's do that. Going to where my velocity was, velocity is 12t squared plus 5. Acceleration is going to be the derivative of that. So, one more time. Limit as, now how about if I use the other method this time just for funsies? The limit as t goes to a of 12t squared plus 5 minus 12a squared plus 5 all over t minus a. Just showing that you can use either definition. Now here what I'm going to do is distribute the minus and also rearrange the terms a little bit. We saw one like this earlier. Oh, we can just cancel the plus 5 minus 5. That's cool. And now we're going to factor the 12 out of the numerator. And then it dawns on us, oh hey, we have t squared minus a squared. We can factor that. That's a difference of squares. So the limit as t goes to a of 12 times the quantity t minus a times t plus a all over t minus a. Cancel the t minus a's. And now you have, when you put a in for t, 12 times a plus a. So 12 times 2a is 24a. So that is the derivative of velocity at a. So the derivative of velocity at t would be 24t, and that is acceleration. Back up to the answer blank. A of t is 24t. And finally, find the acceleration at time 3 seconds. Just plug in a 3. 24 times 3, and we get 72. 72 meters per second squared. Whew. Okay. So, lots of good things to know from that problem. Acceleration is the derivative of velocity. Velocity is the derivative of position. What's the derivative of acceleration? Is there a rate of change to your rate of change? There is. It's called jerk. It's kind of funny. And we even have derivatives of that. All right. We have made it to the end of a very long lesson, and your assignment is to do My Open Math number 10. Thanks, everybody.